Hello everybody and welcome to our lesson on 3E exponential equations. So we're going to take a look over here. Okay, and this discussion comes from page 92 of your text. Remember that an exponential equation is an equation in which the unknown occurs as part of the index or the exponent. For example, 2 to the x equals 8 and 30 times 3 to the x equals 7 are exponential equations because x is the exponent, not the base. There are a number of methods we can use to solve exponential equations. These include graphing, using technology, and using logarithms, as well as some algebraic techniques. Okay. In this section, we're just going to look at using algebraic techniques. So if the base numbers are the same, we can equate exponents. That's our big idea. Okay, so if I have the same base, then these exponents must be the same. So let's take a look at an example. If we have 3 to the x equals 81, our goal is to rewrite both of those with the same base so that we can equate the exponents. In this case, we're going to rewrite as powers of this with the same base, where 81 could be written as 3 to the exponent 4. And since 3 to the x is equal to 3 to the 4, their bases are the same, the exponents must also be the same. That's our simplest case. When we have something like this, 4 to the x plus 2 equals 128, we're going to start by rewriting as powers with base 2. Okay? If I could have written 128 as a power with a base 4, I would, but I can't rewrite 128 with base 4. I can write both of them with a base of 2, though. So I'm going to rewrite 4 as 2 squared and raise it to the same exponent, x plus 2, and rewrite 128 as 2 to the 7. Then I'm going to use a little bit of algebra here. I'm going to use my exponent laws and multiply this power times this exponent. So 2 times x plus 2 times 2 gives me 2x plus 4. Now I have the same base, therefore the exponents must be equal. So I'm going to equate the exponents. So 2x plus 4 equals 7, and bring the 4 over to the right-hand side. I get 2x equals 3, and solve and get x equals 3 halves. For example C, we want to rewrite 1/5 as a power with base 5. So I know that that's 5 to the negative 1. Now I have a single power equal to another single power with the same base, so I can equate the exponents and solve for x. We have a few more examples here. Just going to bring this down, drag it a bit so that we're not so distracted. Okay, in this case, we can rewrite 9 to the x and 3 to the x as powers of base 3. So 9 is 3 squared. Remember that we can interchange those exponents. 3 squared to the x is the same as 3 to the x squared. And then I can see that I have 3 to the x squared minus 3 to the x and minus 6. I brought everything over to the left side. And now I can factor it much like we did in the previous video. Okay, so I'm looking for two numbers that multiply to give me negative 6 and add to give me negative 3. Oh, sorry, negative 1. The coefficient here is 1. So that is negative 3 and positive 2. Now, so I factored my expression. It's equal to 0, which means either this expression, 3x minus 3, must equal 0, and in that case, x has to equal 1, or 3 to the x plus 2 equals 0, but it's not possible for 3 to the x to equal negative 2. We can set it equal to 0, but it's inadmissible because there's no way that this exponent on x can do anything to make this value negative. So there's one solution, even though we had two factors. In this case here, remember that we're going to divide both sides by 7 first, then rewrite 8 as a base with a base 2, and then I can equate the exponents. And last here, again, we want to focus on what could we rewrite both of these, what base could we use to rewrite both of these, and the base is going to be 3. So I can rewrite 9 as 3 squared and 1/3 as 3 to the negative 1. I can simplify those exponents by expanding here and here. Then I can, since I have a single power equal to another single power with the same base, I can equate the exponents and solve for x. Notice that when I do this, I bring